confused why we're going to be.
All right. Dave. All right, so we're gonna do multivariable systems. The concept is actually very similar when it's 2 variable versus 3 variable versus 4 variable versus X variable. So the concept is still the same. We're gonna use substitution. This is called back substitution because you keep going back and back from the substitution. But write down the problem so we could just use this as an example. Yeah, because it's introduction. It's just introducing the thing. Of course, this is a perfect situation where you already know basically the value of one variable.
This is the season finale with the cliffhanger. It's ready to.
No, this is the opening, right? This is like everything's peaceful, and then, and then
we have the rising act.
and then there's a 4th degree, and then you don't know what's happening.
Landing with the input.
It's not rising; it just shoots up.
Did you ever watch the show Scrubs?
Sometimes, like just random episodes. I never watch it consistently.
Good.
I agree. All right. So with the substitution, we need to find, instead of 2 variables, X and Y, we need 3 variables, X, Y, and Z. And when we write it as an ordered pair, it's X, or not ordered pair, ordered triple, X, Y, Z. Usually you do it alphabetical, or depending on the scenario, might be the most dependent to the most independent.
Wait.
Or most independent to the most independent.
We gotta stick with the alphabetical part.
Yeah, we'll just skip that.
Okay.
So first off, we get a freebie right on the bottom. Z is 2. So we already got 2. That's one of the answers. That's really nice. And if it was 1 variable, anyone could do that. Well, anyone who knows algebra 1 could do that. So then we could take that Z, and we know that's one of our solutions. We can use that to find another solution. So let's look at the second equation over here.
Well, anyone that doesn't, any equation that there's 2 variables, one being Z would be the same one.
Exactly. So then here we could use this equation and plug in that Z we found earlier. So Y plus 3 times 2 equals 5. Exactly. It's the twist. And then that's -1. Yeah, you've seen it so many times. You just don't get surprised anymore.
Yeah, no, I'm waiting for the twist. The twist is when you have the Z having multiple issues.
Yeah.
Then you have to find 2 equations that have 2 variables, same 2 variables,
So then this one,
or the same 3.
now we have -1, we found it here. And we found 2, we found it here. So now we can use that to our advantage and use it to find the last variable, which is the X. X minus 2 times -1 plus 3 times 2 equals 9. A little bit of algebra. X equals, is it not 0? This is +3. This is 6, 9 is.
Because it's X plus 2 after you.
Oh, yeah, that's right. So 1. You're right.
That's John Mitchell.
Thank you, Dylan.
So your final answer is 1, -1, 2. So that's an ordered triple.
I have a question.
Yes.
I have a motion to call the Z a Z.
You could call whatever you want.
Also, from now on, zeros are naught.
No, that's not going. All right. Now, this is the twist. What happens when you don't get a freebie, essentially?
Look up pair variables.
Shh, let me teach you. All right. So everyone copy down the next problem. And this is called row operation, which then we're going to use row operation to help us eliminate.
When writing exactly, reorder it.
I have no clue what you just said, man.
When writing,
What did you just say?
when we writing exactly, reorder it.
Yes, you can reorder it.
I'll see if it's matches in the problem.
What's up?
English is not first language.
Fair enough. All right. Let's see.
That recently came out.
So what I heard, that was on Zoom.
Yes, but
I remember.
English class.
No, because I was
Oh,
there.
come on.
No, I was there.
I get the fact that you're there, but I was like, I don't know.
I'm always there.
Hey, yeah.
All right, okay, guys. Guys, okay, our goal is to, in order to be able to do this, we're gonna have to eliminate all the variables down to one. Just like the previous question where we had z by itself, our goal is to get one of these equations to have one variable by itself. So our goal is to reduce it all the way down to one variable. And we could do that with something called row operations. We're allowed, just like system of equations, to add one equation directly to another. So let's start off. Exactly. We're going to cancel out for this one. We're going to do this. We're going to do, if I call this, by the way, let's call this row 1, row 2, and row 3, just so we have a reference. All right, I'm going to make a new row 2. So I'm going to do row 1 plus row 2. I'm going to make a new row 2. And in order to do that, I'm going to do row 1 plus row 2. So my row 1 stays the same. My second row, I'm going to change it. So now this is going to be, I'm going to add these, right? So x minus x, that's 0. So that doesn't exist. Negative 2y plus 3 is just a positive y. 3z plus 0 is 3z. And 9 plus negative 4 is 5. So I took row 1, which is here, and added to row 2, which is here. What's up?
Why is the top off now? That you just combined them?
I'm using it to make a new row. I'm not trying to, I can't just erase it and make it disappear.
Say system of,
We're not getting rid of row 2, we're making a new row 2.
this is an equation. For system of equations, when you add them, there's not 2 rows. It's just one turns into one.
No, we're not adding.
So
we're not
when you
adding-
do that, we always reduce it to 1 because we're already ready to finish. But it doesn't actually become 1. It's just that we're combining 2 functions to make a new function. Here, we're doing the same thing. It never actually disappears because if it actually disappeared, we wouldn't be able to plug it back in.
What's this whole thing about making a new row 2? Wouldn't this be a row 4? What you're making?
You could do it with a row 4 if you're doing, especially with matrices, you'll do it with a row 4, but
Because row 2 will still be used later on.
What's up?
Row 2 will still be used later on, the original.
yeah, exactly. And then
Yeah, making things look painful.
2x, was it really painful? It was like just calculator stuff. Wasn't it?
No, doing it by hand. Doing it
Oh.
by hand was absolutely painful.
Yeah, that's a little painful.
In terms of handwriting, I cannot think of a list.
We did it freshman year. And last.
You should have done it freshman
Yeah,
year.
freshman year was by hand. Last
You
year.
did it at the very end of freshman year.
We did it actually, we did it right after the winter because, Molly didn't want person.
So then, wait a second. You did 1 and 3?
I say it's easy.
Okay, so our goal is to eliminate, again, one of the variables. So I want to reduce this x to only like, so I want to kind of make it look like this, where I have 3 variable, 2 variable, 1 variable. So I want to make this x disappear on the bottom. You could technically make it disappear on the top, but we'll just work the way I said it. So here, I want to make a new row 3.
Multiply the top by 2 and then subtract.
Good, so I'm going to do it, I'm going to show it like this though. Yeah, so I'm going to do 2 of row 1 minus row 2. You could technically also do negative 2 of row 1 plus row 2. That's the same thing. Alternate version could be, if you're more used to that, negative row 1 plus row 2. Negative 2 row 1 plus row 2. And this is going to make a row, I'm sorry, I said row 2, row 3, row 3. Because remember, we're trying to get the x's out of 2 and 3. So row 1's still staying the same. Row 2 was not interact with, so it's going to stay the same. Row 3 is now new. So you could do it on the side. I'm just gonna do it like out loud. 2x and 2x, we're gonna subtract that. So that's 0. Plus 2y minus, this is gonna be
It's -2y.
negative 4y plus negative 5 is negative 9y.
No.
Okay.
It's negative 4y plus 5y.
Oh, you're right. So it's positive 1.
Yeah,
Because it's 2 minus 1.
it's negative 4 minus negative 5.
Yeah.
Oh, you're right. Thank you.
And then what's the next one? 3 minus, no, 6 minus 5. So that's 1y or 1z. And then 18 minus 1 is 1.
What?
18 minus 17 is
Oh,
1.
I've seen the five, sorry.
Yeah.
Right, I don't have the order, I was doing 9 minus 5.
Again, we're not showing our work, so this is why we're getting confused, which is we should have worked. Okay,
No, it makes sense,
Yeah, I
it's
don't
just
know how.
the ordering, how you write it.
okay, remember, goal to reduce it down to one variable.
3, 2, 1. You got the y and z.
So what can I do with equation 2 and equation 3?
You can subtract it, so y minus 1.
So now I'm gonna take my current row 2 and subtract row 3 from it. You could do it the other way too, row 3 minus row 2, to make a new row 3. So x minus 2y plus 3z equals 9. The first row was not interacted with. Y plus 3z equals 5. Here we're subtracting, so y minus y is 0. 3 minus 1 is 2. And 5 minus 1 is 4.
Why can't you just, for the y plus z equals 1 minus the z and say y equals.
And do like substitution? You could technically do it like that too. Because here you have like basically a normal system of equations. So you could technically do what you
No,
said.
but you wouldn't want to do that, because it's easier to just do the 3b of z's.
I'd rather just keep it consistent, so that's why I do it.
What?
All right, so from here, now we got down to that easy part where we just do one variable at a time.
And look at the what's before.
Yes. So we'll do the easy part, comma, comma. So here, we're gonna get z equals 2, because I will just divide 2 on both sides. I take that z and plug it into equation 2. So y plus 3 times 2 equals 5. A little bit of algebra.
Why can't you just plug it to the bottom one, y plus z, like y plus 2 equals 1?
Yeah, you could do it like that too.
Much easier.
Yeah, you could do it into the original, actually. So you can do it.
These all, you use all of it.
I like a test or something, we didn't have to get into like, we didn't have to like write down the side that it's those, that like, it would be those 3 equations at the end.
You have to reduce it down in order to do
I
it.
reduce it down, I specifically just say that it goes.
As long as you follow it. So like, are you showing like these things where I know, you need to tell me that. But you're telling me, you gotta tell me what you're subtracting so I can follow it, or we're gonna have the same problem with the last test and be like, what the heck is happening?
Yeah, but that was like 2 weeks on
I got you, but still, the best thing to do is kind of like this. This one, so y equals -1. And notice if you plugged it in here, you would also get -1. And then here, we're gonna plug it into the top, so we need all 3 variables. So this one is x minus 2 times -1 plus 3 times 2 equals 9.
1.
3, wait, is this again the same problem?
Yeah, I said this earlier.
Oh, it was the same
It's
problem.
the same equation last one.
Look at that.
Nice job, Bash.
Well. Yeah.
Thank you for that.
If we took the 2 out here, I think it would be the same. Yeah, you're right. You just divide everything by 2 there. And then we got our 3 answers. 1, 1, 1, -1, 2.
How, what do you need to draw for the 8 time?
And a 3-dimensional plane? No, not on a piece of paper at least. If you want to use some string and some suspension, sure. But
We're gonna put code blocks, cut it into 3 planes.
you don't need to do that though. You could just mark it on the ground. Like the blue tape is your x-axis, you have another tape that's your y-axis, and you know vertically is your z-axis. Then you just make a string.
That's just hard processing them.
I mean, but that's actually 3D. What are you asking?
No, Z is vertical.
Or whatever, yeah. C should be
Z is
forward,
this
back.
way.
Yeah, def.
It's through the paper.
Yeah. I think we literally have 1 minute left.
Yeah, we do.
Am I correct? Yeah. I forgot what times
never
or
mind.
normal times.
We don't have
Yeah. Guys on Zoom, you can just type here for your attendance. Guys here, just chill out for a minute. I don't know there's bells, so I'll let you go. You're supposed to spit at the auditorium. If you can't do that now, I guess you gotta spit at Ali's office. Yeah, we're done. And I don't think there's bells for the mock, maybe?
Since 2 + 2, never.
Honestly, though. Not in high school.
We didn't know freshman, so you had to take multiplication chart.
You just gotta go back.
Did anyone have the composition notebooks that had a multiplication table, 12 by 12? I think that's why everyone knows 144 is 12 squared. It's because of that little table.
No, it's just a math number. The 11, 12, 13 is
Or
just math number.
14 too, though.
14 is ugly.
What do you mean? If it's 169, the other one's 196. That's the cool part about it.
No. 11, 12, 13, 15, 14 is ugly.
No, it's not. It's the same as 13. How are you gonna say that? It's just reverse.
Wait, no, it's only 13. 13 is 169.
And then 14 is 196.
Oh, it's because, yeah, no, it's not.
That's so. What do you?
No,
Okay,
1.4 is my multiplication table stuff as well.
there you go.
1.4 is cool. 12 is a base 12 is a very common thing.
That's fair.
11 is just because 121, 121 is
Yeah.
now 11.
Yeah.
And 13 is 169, 15 to 225.
But 14 is 196, which is a reverse of 169. It's nice. It's the same kind of nice.
It's not.
16, we have debate.
16, we get the action.
Yeah. What's 16?
No, 20s.
126?
What?
20s where we get some real shenanigans.
20 is solid though, 2400. That's easy. Easy peasy. Everyone have a wonderful day.
400 is a cool number. It's a boring one.
But it's solid.
Yeah, it's solid, but it's just whack.
Yeah, yeah. It's consistent. You gotta like him. He's not fun, but he'll do the job every time.
It's, what is it?